Hello students, welcome to this lecture on probability. In this lecture, we will cover example 19 to 21 and then we will discuss exercise 13.3 question number 1 to 4. So let's get started. This is disclaimer. In today's lecture, first we discuss example 19 to 21. After that, we will discuss exercise 13.3 question number 1 to 4. I hope you are with your notebooks and pens ready. So let's get started. In this example, we have three machines A, B and C and they make bolts. Machine A makes 25% of bolts, B makes 35% and C makes 40%. Of their bolts, 5%, 4% and 2% are defective respectively. So a bolt is picked at random, okay, and found to be defective. So we need to find the probability that this defective bolt was made by machine B. So first of all, try it yourself and then see solution. Let's solve this example step by step. Let events B1, B2 and B3 be mutually exclusive and exhaustive events. Okay, this means they cover all possibilities and no two can happen at the same time. They form a partition of the sample space. So B1 represents the event that the bolt is manufactured by machine A. It is a specific outcome in a sample space of possible manufacturing processes. B2 represents that the bolt is manufactured by machine B. B3 represents a bolt made by machine C. Clearly, B1, B2, B3 are mutually exclusive and exhaustive events and hence they represent a partition of the sample space. Let the event E be the bolt is defective. The event E occurs with B1 or with B2 or with B3. Okay, given that probability of B1 equals 25%, 25% equals 0.25. Okay, and probability of B2 equals 0.35 and probability of B3 equals 0.40. Again, probability of E given B1. This is meaning of that probability that the bolt drawn is defective given that it is manufactured by machine A. Okay, and this is given to us 5%. Okay, and 5% equals 0.05. Now, similarly, you can find probability of E given that B2 equals 0.04 and probability of E given by B3 equals 0.02. Hence, by Bayes theorem, we have probability of B2 given E equals probability of B2 times probability of E given that B2 divided by probability of B1 times probability of E given that B1 plus probability of B2 times probability of E given that B2 plus probability of B3 times probability of E given that B3. Now let's substitute the given values into the formula and then we will get 0.35 times 0.04 divided by 0.25 times 0.05 plus 0.35 times 0.04 plus 0.40 times 0.02. After simplifying, the numerator will become 0.0140. Okay, and denominator will become 0.0345. So after further simplifying, we will get 28 divided by 69. Okay, so probability of B2 given that E equals 28 divided by 69. Clear? And this is our final answer. So the probability that it is manufactured by the machine B, okay, machine B is 28 divided by 69. So I hope this is clear to all of you. So now let's move to the next example. In this example, we have a doctor can arrive by train, bus, scooter, or other means. Okay, so the probabilities for each are 3 by 10, 1 by 5, 1 by 10, and 2 by 5 respectively. Okay, so the chances of being late are 1 by 4, 1 by 3, and 1 by 12. So if he comes by train, bus, and scooter respectively, but if he comes by other means of transport, then he will not be late. Okay, so when he arrives, he is late. So what is the probability that he comes by train? So first of all, try it yourself and then see solution. So let's solve this example step by step. First, let E be the event that doctor visits the patient late. Okay, and let T1, T2, T3, and T4 be the events that the doctor comes by train, bus, scooter, and other means of transport respectively. So given probabilities, probability of T1 equals 3 divided by 10. Probability of T2 equals 1 divided by 5. Probability of T3 equals 1 divided by 10. Probability of T4 equals 2 divided by 5. Okay, so these represent the probabilities of 4 mutually exclusive events and their sum is 1. So they form a complete set of outcomes. So probability of E given the T1 equals probability that the doctor arriving late comes by train equals 1 by 4. Similarly, probability of E given that T3 equals 1 by 12 and probability of E given that T4 equals 0 since he is not late if he comes by other means of transport. Therefore, by Bayes' theorem, we have probability of T1 given that E equals probability that the doctor arriving late comes by train equals probability of T1 times probability of E given that T1 divided by probability of T1 times probability of E given that T1 plus probability of T2 times probability of E given that T2 plus probability of T3 times probability of E given that T3 plus probability of T4 times probability of E given that T4. Okay, so this is the formula for Bayes' theorem. So now we will substitute the given probabilities and then we will find probability of T1 given that E. After substituting the given values, we get 3 by 10 times 1 by 4 divided by 3 by 10 times 1 by 4 plus 1 by 5 times 1 by 3 plus 1 by 10 plus 1 by 10 times 1 by 12 plus 2 by 5 times 0. Okay, so further simplify it and you will get 3 by 40 times 120 upon 18 which is equal to 1 by 2. Hence the required probability is 1 by 2. So I hope this example is clear to all of you. So now let's move to the next example. In this example, we have a man is known to speak truth 3 out of 4 times. Okay, so we have given here a man is known to speak truth 3 out of 4 times. So he throws a die and reports that it is a 6. So find the probability that it is actually a 6. Okay, so first of all try it yourself and then see solution. So let's solve this example step by step. Let E be the event that the man reports that 6 occurs in the throwing of the die, and let S1 be the event that 6 occurs and S2 be the event that 6 doesn't occur. Okay. So now the probability of event S1, which is rolling a 6, okay, is calculated as the number of favorable outcomes divided by the total number of possible outcomes. Thus, probability of S1 equals 1 by 6. The probability of event S2, which is that a 6 does not occur, okay, and it is calculated as 1 minus probability of 6 occurs, okay, and since the probability of rolling a 6 is 1 by 6, then probability of S2 equals 1 minus 1 minus 5 by 6 equals 1 minus 1 by 6 equals 5 by 6, okay. So now probability of E given that S1 equals probability that the man reports that 6 occurs when 6 has actually occurred on the die, and the probability that the man speaks the truth is 3 out of 4, okay. So this means he tells the truth in 3 out of every 4 situations. So probability of E given that S1 equals 3 by 4. Then probability of E given that S2 equals probability that the man reports that 6 occurs when 6 has not actually occurred on the die, okay. So this is equal to probability that the man does not speak the truth, okay, and probability of the man speak the truth equals 3 by 4. So probability that the man doesn't speak the truth equals 1 minus 3 by 4 equals 1 by 4. Thus by Bayes theorem we get probability of S1 given that E equals probability that the report of the man that 6 has occurred is actually 6. Okay, this is equal to probability of S1 times probability of E given that S1 divided by probability of S1 times probability of E given that S1 plus probability of S2 times probability of E given that S2. This is equal to 1 by 6 into 3 by 4 divided by 1 by 6 times 3 by 4 plus 5 by 6 times 1 by 4. Okay, and now simplify numerator and denominator. You will get 1 by 8 times 24 upon 8 equals 3 by 8. Okay, so therefore the probability that it is a 6 actually a 6 equals 3 by 8. Clear? I hope it's clear. Hence the required probability is 3 by 8, and this is our final answer. Now we will see a remark. Okay, so here note this remark: a random variable is a real valued function whose domain is the sample space of random experiment. For example, consider the experiment of tossing a coin 2 times, okay, in succession. Then sample space of the experiment S equals HH, HT, TH, TT. And then let X denote the number of heads of 10. So for each outcome, the values of X are X of HH equals 2, X of HT is 1, X of TH is 1, and X of TT equals 0. And more than one random variables can be defined on the same sample space. For example, let Y denote the number of heads minus the number of tails for each outcome of sample space S. Then for each outcome, the value of Y are Y of HH equals 2, Y of HT equals 0, Y of TH equals 0, and Y of TT equals minus 2. So now we can conclude that x and y are two different random variables defined on the same sample spaces. Now, let's look at question number 1. In this question, we have given that an urn contains 5 red and 5 black balls. A ball is drawn, okay, noted, and put back. So then 2 more balls of the same color are added. Now a second ball is drawn. We need to find the probability that the second ball is red. Okay, so first of all, try it yourself and then see solution. So now let's solve this question step by step. The urn has a total of 10 balls with 5 red and 5 black. Then let a red ball be drawn in the first attempt. So therefore, probability of drawing a red ball equals 5 by 10 equals 1 by 2. So if 2 red balls are added to the urn, then the urn contains 7 red and 5 black balls. Then probability of drawing a red ball is 7 by 12. Now let a black ball be drawn in the first attempt. So therefore, probability of drawing a black ball in the first attempt is 5 by 10 equals 1 by 2. If 2 black balls are added to the urn, then the urn contains 5 red and 7 black balls. Then probability of drawing a red ball equals 5 by 12. Therefore, probability of drawing second ball as red is 1 by 2 times 7 by 12 plus 1 by 2 times 5 by 12 equals 1 by 2 times 7 by 12 plus 5 by 12. Okay, which is equal to 1 by 2 times 1 equals 1 by 2. So therefore, the probability of drawing second ball as red is 1 by 2. So I hope this question is clear to all of you. So now let's move to the next question. So now let's look at question number 2. In this question, we have a bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Okay, so then find the probability that the ball is drawn from the first bag. So first of all, try it yourself and then see solution. So let's start the solution step by step. First, let E1 and E2 be the events of selecting the first bag and second bag respectively. Therefore, probability of E1 equals probability of E2 equals 1 by 2. Then let E be the event of getting a red ball. It implies probability of A given that E1 equals probability of drawing a red ball from the first bag equals 4 by 8 equals 1 by 2. And then probability of A given that E2 equals probability of drawing a red ball from the second bag equals 2 by 8 equals 1 by 4. Then the probability of drawing a ball from the first bag given that it is red is given by probability of E2 given A. By using Bayes theorem, we obtain probability of E1 given that A equals probability of E1 times probability of A given that E1 divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2. Then substituting the given values, then we will get probability of E1 given that A equals 1 by 2 times 1 by 2 divided by 1 by 2 times 1 by 2 plus 1 by 2 times 1 by 4. And this expression will become 1 by 4 divided by 1 by 4 plus 1 by 8. And this is equal to 1 by 4 divided by 3 by 8 equals 2 by 3. Therefore, the probability of drawing a ball from the first bag, given that it is red, is 2 by 3. Now, let's look at question number 3. So, given 60% students are hostelers, 40% are day scholars, 30% hostelers get A grade, 20% day scholars get A grade, and a student is chosen at random and has an A grade. Find probability that the student is a hostelers. So first of all, try it yourself and then see solution. So let's start the solution step by step. So first, let E1 and E2 be the events that the student is a hosteler and a day scholar respectively, and A be the event that the chosen student gets grade A. Therefore, probability of E1 equals 60% equals 60 divided by 100 equals 0.6, and probability of E2 equals 40%, and this is equal to 40 by 100 equals 0.4. And probability of A, given that E1 equals probability of student getting an A grade is a hosteler, equals 30% equals 0.3. Then probability of A, given that E2 equals probability of student getting an A grade is a day scholar, equals 20% equals 0.2. In probability, E1, given that A, means the chance that a student is a hosteler given they have an A grade. So it's calculated as probability of E1 intersection A divided by probability of A, where E1 is being a hosteler and A is having an A grade. So by using Bayes theorem, we obtain probability of E1 given that A equals probability of E1 times probability of A given that E1 divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2. After substituting these values into the formula, then we will get 0.6 times 0.3 divided by 0.6 times 0.3 plus 0.4 times 0.2. Then if we further simplify it, then you will get 0.18 divided by 0.26. Okay, so probability of E1 given that A equals 0.18 divided by 0.26, and this is equal to 18 by 26, and further simplify it and then you will get 9 divided by 13. Therefore, the probability that a randomly chosen student is a hosteler given that he has an A grade is 9 by 13. Now look at question number 4. So the question says a student either knows the answer or guesses. Okay, so the probability he knows is 3 by 4 and he guesses with 1 by 4. If he guesses he is correct with 1 by 4 chance, so we need to find the probability that he knew the answer given that he answered correctly. Okay, so first of all, try it yourself and then see solution. So let's start the solution step by step. Let E1 and E2 be the respective events that the student knows the answer and he guesses the answer. And then let A be the event that the answer is correct. Therefore, probability of E1 equals 3 by 4 and probability of E2 equals 1 by 4. The probability that the student answered correctly given that he knows the answer is 1. Therefore, probability of A given that E1 equals 1. And then probability that student answered correctly given that he guessed is 1 by 4. Therefore, probability of A given that E2 equals 1 by 4. Then the probability that the student knows the answer and given that he answered it is correctly. Okay, so it is given by probability of E1 given that A. So by using Bayes theorem, we obtain probability of E1 given that A equals probability of E1 times probability of A given that E1 divided by probability of E1 times probability of A given that E1 plus probability of E2 times probability of A given that E2. Then probability of E1 given that A equals 3 by 4 times 1 divided by 3 by 4 times 1 plus 1 by 4 times 1 by 4. And this is equal to 3 by 4 divided by 3 by 4 plus 1 by 16. Further simplify it and then you will get 3 by 4 divided by 13 by 16 equals 12 by 13. So probability of E1 given that A equals 12 by 13. Therefore, the probability that the student knows the answer given that he answered it correctly is 12 by 13. And this is our final answer. So I hope this question is clear to all of you. So that's all for today's lecture. So thank you for your attention. I hope this lesson was helpful.